So here's what you need to know. We've talked about quadratics, but now we're going to talk about all the rest of the polynomials. So a polynomial function has to have real coefficients, so no imaginary numbers, and it has to have whole number exponents. They're always smooth and they're continuous. So for example, absolute value, that's not smooth. That's not a smooth curve, right? So absolute value is not a polynomial function. A real number excludes imaginary numbers. A whole number is 0, 1, 2, 3. Standard form, I think you know standard form, highest to lowest exponent. And the degree is the highest exponent, and the leading coefficient is whatever comes in front of that highest exponent term. So like this should all be vocabulary you're already familiar with. So should this. I just felt like I needed to put it out there again so you had it, kind of like your, Bible of information here. But constant function has a degree of 0, like a horizontal line, y equals 7. A linear function comes next. It has a degree of 1. So this function has a degree of 1, y equals 3x plus 4, right? That's just slope-intercept form. You already reviewed how to graph that. Quadratic functions have a degree of 2. This is in standard form. 4x squared is coming first. And then cubic. Quartic means 4th degree. And then after that, we just say like 5th degree, 6th degree, 7th degree. So that's just called an nth degree function. So 5th or 6th. So this is any power you want, ninth degree function. And you should know monomial, binomial, and trinomial. Just means 1 term, 2 terms, or 3 terms. I've already used the term binomial today, but we just need to have that common mathematical language. Like this is a linear binomial, but this is a linear monomial. These are all polynomials. So the word polynomial makes you want to think like it's more than 1 term, but a linear function with 1 term is still under this branch of polynomial functions. It's a big classification. So any questions about that? So on your quiz, on your summative assessment, I might ask you a bunch of questions. Hey, what's the degree of this? Write it in standard form. Name it. So you'd say it's a, quadratic trinomial. So hopefully you would know some of those vocabulary terms. The quiz will help you gauge if you know it, because the summative will override your quiz anyway if the summative's higher. So the quiz is just kind of a practice. This at the bottom, I only put on there because a lot of you are juniors, so you're going to be taking the SAT in March. And sometimes the SAT will throw kind of these types of terms on it and ask you the degree. To me, this is not a polynomial, so I'm not going to assess you on it in polynomial world. I just wanted to show you that if you had like 4y cubed, that's considered a 3rd degree monomial, even though y cubed is not like a function that we study. Or like 3xy cubed, to me, this is just an expression. They give this a degree of 4. So all the variables that are being multiplied together, you get to add up the degree of each one. And to me, this is kind of a different rule than what I'm telling you up here. Like up here, that is a 2nd degree function. We don't add this x squared and this x and call that cubic, right? So this is what I want you to know for polynomial world, but the SAT might throw one of these on there. Like that's considered a 5th degree term, but I can't graph x squared y cubed. It's not a polynomial. Does that kind of make sense, the difference? So I just don't want you to be thrown if the SAT throws something on there and say, hey, what's the degree of this monomial? They want you to add up the powers that are all being multiplied together. So I kind of put that on there as an aside. Like I'm not going to assess you on it, but for SAT in March, I am going to do some SAT prep starting after February vacation. So I'll give you more information on that. So here is a question you might get asked on like a quiz or a test. Identify if it's a polynomial function, write it in standard form, state the degree, state the leading coefficient. Can anyone identify, so 1 out of these 4 is not a polynomial. Which one fails the polynomial test? Can you tell? Only 1 out of the 4 will fail. So which one fails? It doesn't have a real coefficient or it doesn't have a whole exponent. Krishna? Number one actually passes. Are you looking at pi? So pi is a real number. It's just irrational. So it's 3.14159. But you can have that as a coefficient because it's a real number. So one actually passes as a polynomial. It just has an irrational coefficient right there. 2, 3, or 4? Which one do you think, Lily? 3 actually passes. Are you thinking of this square root of 3? So this is actually also irrational. If it had been the square root of 3x and the x had been under the square root, it would have failed. But because the square root of 3 is just the number 1.7, it actually passes. You also could not have negative under the radical. But see how the negative is outside the radical? So this actually passes. It's this one that fails. See how it has a fractional exponent? So this is the only one that's not a polynomial. So I don't have to go any further on number 4. So for the other ones, I'll do example 1 for you. If I put this in standard form, 2x cubed would come first, then 2x squared minus pi x, and then plus 4 would come last because it was a constant term. They want you to state the degree and the leading coefficient. So this has a degree of 3 because x cubed is the biggest power, and the leading coefficient is this 2 that comes in front of x cubed. So the leading coefficient is positive 2. That's going to be important tomorrow when we look at end behavior of a graph. And then f of x just means y equals. So you can go ahead and put 2 and 3 in standard form and state the degree and leading coefficient. And I'm just going to pause my video. But number 2, I got degree of 9, leading coefficient of negative 2. And then number 3, the degree was 3 and the leading coefficient was a half. So I wanted to talk about zeros of a polynomial. And the zeros, this is why you need to know how to factor, is to find zeros. So I think some of you might have seen this in Algebra 2, like if it bounces off the graph or cuts through, but I'm not sure if all of you did. So the zeros of a polynomial are the x values that make the polynomial 0, right? They're the x-intercepts. If a polynomial can be factored, the zeros are the x values that make one or more factors equal 0. A polynomial can have at maximum the same number of zeros as its degree. For example, a quadratic function could have 2 x-intercepts, but it could have fewer. So when they ask you how many maximum zeros you could have, right, a quadratic could have 2, but it could have 1 if it just bounces off, and it could actually have 0 x-intercepts. So they might ask you the maximum number of zeros. If it's quadratic, it could have 2, but it could also have fewer than that. So this just says, let's factor this and find the zeros and then sketch the graph. So what are the factors of negative 12 that add up to positive 4? What would you say, Krishna? So x plus 6, x minus 2. Those are my factors, right? If I FOIL this back out, I will get back to the original trinomial. So now I want to know what the x-intercepts are, the zeros. So what does that x value have to be? And what does that x value have to be to make it 0? Yeah, Krishna? So x is equal to either negative 6 and 2. Those are my two x-intercepts. And then if we wanted to, we could, find the vertex. But we know that this is going to have an x-intercept at negative 6, an x-intercept of 2. We know that it's concave up. I didn't take the time to find the vertex, but it just said sketch the graph. So I just found my two x-intercepts and sketched the graph. Concave up, right, because it's x squared. So something new that you might not have seen before is the multiplicity of a 0. In regular Algebra 2 land, we would have covered polynomials, but we might have gotten shortened depending on when you took Algebra 2. So it says, in factored form, the multiplicity of a 0 is the degree of that factor. So this factor has a degree of 1. This factor has a degree of 1. So each of these zeros has a multiplicity of 1. So it says, here's another example. If you have x times x minus 5 squared, then 0 is a 0 with a multiplicity of 1, right? If I plug in 0 right there, 0 times anything is 0, and this is x to the first power. And it says, but 5, because 5 minus 5 is 0, 5 is a 0 with a multiplicity of 2. So see how there's a 2 right there? 5 has a multiplicity of 2, but 0 only has a multiplicity of 1. And it says, let's just sketch this graph using a graphing calculator. You don't have to get one out right now. I'll just plug it in for you. But just x times x minus 5 squared. I just want to show you that there's something special going on at these x-intercepts. Why do I see this reflection? Let's see. So you can kind of see this. All right, so do you see what's happening at these x-intercepts? What's happening at this x-intercept is it cut through the x-axis. What happened at this x-intercept is it bounced off the x-axis. So the multiplicity is creating either a cut through x-intercept or a bounce off x-intercept. So you're going to use the multiplicity without the graphing calculator to sketch the graph on your test. Not Wednesday, because this is kind of too new. But if you plotted your x-intercepts, right? I know I have an x-intercept at 0. I know I have an x-intercept at 5. We're going to learn about end behavior, what makes them go up and down. But we can just sketch that this went up and then it bounced off, right, at 5. So bouncing off versus cutting through the x-axis is created by an even or an odd multiplicity. I think of even as kind of like a quadratic, right? So kind of like a quadratic bounces, or a linear function cuts through. Odd functions will cut through the axis. All right. So here's a little bit more, so it says if you have odd multiplicity, the graph will cross the x-axis. Even multiplicity, the graph will basically bounce off, touch or bounce off, touch the x-axis without crossing it. So for these two examples, we're just going to state the x-intercepts, or the zeros, what the multiplicity is, and then sketch the graph. So for this, they're both in factored form, so that's nice. So what are my two x-intercepts? In factored form, my two x-intercepts are what and what? 0 and positive 1, right? Because 1 minus 1 is 0. So what's the multiplicity of each of those? So 0 has a multiplicity of what? 2, right? X squared. If I plug in 0, 0 times anything is 0. So it has a multiplicity of 2, which is even. And 1 has a multiplicity of, see how the power there is 1? So it has a multiplicity of 1, which is odd. So when I sketch the graph of this, x squared times x minus 1. We know that it's going to bounce off the graph at 0, and then it's going to cut through the graph at 1. And if I go in just a little bit closer, negative 5, 5, negative 5, 5, it does actually bounce off. See how it bounces off? It goes slightly below the axis, and then it cuts through. So if you just wanted to sketch, okay, it bounces off at 0, cuts through at 1, kind of comes up, bounces off, and then cuts through. Just so that you have a reference, because multiplicity seems to be a new idea that students struggle with a little bit if they've never seen it. All right, and then this last one, I have two x-intercepts again, because I have two different factors. X-intercept, multiplicity. So what's my first x-intercept? From this x plus 1 cubed, what do I have to plug in that would make this 0? Negative 1, because negative 1 plus 1 makes that 0. So negative 1 has a multiplicity of 3. And if I wrote this out in factored form, I could actually exaggerate this and say, there, that's my multiplicity of 3, right? That's what x plus 1 cubed means. X plus 1 times x plus 1 times x plus 1. See how it just showed up 3 times? And then this is x minus 1 times x minus 1. right? X minus 1 squared. See how it just showed up 2 times? That's where the idea of multiplicity comes from. So what's my total degree? My total degree is 5th degree, right? X to the 5th. So let's see, because this is in factored form. So you'd have to go to standard form to see X to the 5th. So this is positive 1, and it would have a multiplicity of 2, which is even. So we should be able to predict what's going to happen at those x-intercepts. Ohm? The power of that factor, yes. Very good. And if there's no number, you know it's a multiplicity of 1. So if I plug in x plus 1 cubed and x, what am I doing? Minus 1 squared, right? Zoom 6 again. We know that it's going to, at an odd, cut through, and at an even, bounce off. So -1 is where it's cutting through. So it's coming up, it's cutting through. It has this weird kind of kink in the graph, but whatever. And then it bounces off here and goes up forever. So it doesn't have to be perfect. I really just want you to emphasize we're cutting through the x-axis versus we're bouncing off the x-axis. Does that make sense? So that's where I'm going to stop for today. We'll start next class, or if you want to take a look at it for a minute now, but we're going to start next class with this kind of guided practice to practice what we just learned before we look at end behavior.